All right, guys, this will be it for the day. I'll come back again maybe Monday morning if there's space and availability. All right. So this is chapter 3, problem number 5, guys. All right, chemistry fans, welcome back to Chemistry 1032 problem solving set. My name is Dr. Russell Betts. I will be your guide through this problem. So here we have a heat question. The temperature of the ocean off of Fort Lauderdale in January is 23.5 degrees Celsius. In August, the water temperature increases to 30.0 degrees Celsius. How much energy, and it wants it to be expressed in kcals, must be absorbed by 1,000 grams of seawater to accomplish this rise in temperature? And it gives us a specific heat of water of 0.940 calories per gram per degree Celsius. Wow, there's a lot of numbers going on in this question. So let's carefully jot them down. All right, temperature of the ocean off Fort Lauderdale is 23.5 Celsius. In August, the water increases in temperature to 30.0 degrees Celsius. How much energy? So that's the first thing. We need to know energy. So that's, you can read that as heat. How much heat, energy, heat, equals question mark, and then put the unit, kcal. We want to be in kcals at the end. How much energy in kcals must be absorbed by 1,000 grams? So mass equals 1,000 decimal point grams. That's how much we're going to heat the water up. I'm going to heat 1,000 grams of water up. Whew, man, this is tricky. Let's be careful. All right, so we have two temperatures. So let's just put T1 and T2. T1 is 23.5 degrees Celsius, and T2 is 30.0 degrees Celsius. All right, so we have a temperature increase from winter to summer. And we know the specific heat because it's given to us right there. All right, wow, this is a tough question. Well, first of all, we need to know, how do you figure out what the heat is? Well, the heat, read energy, is grams multiplied by temperature multiplied by specific heat. SH, specific heat. Okay? Well, we have grams. We have 1,000 grams right here. We have two temperatures. That's a little tricky. Let's not worry about that just yet. And we have a specific heat. Okay, so we have everything we need basically. It's just the question just looks hard. It's really not that bad. So again, we have the grams. The grams are right here, 1,000. We have two temperatures. That's a little weird. I'll show you how to do that in a minute. How to work with that. It's not a problem. And we have specific heat. It's right here. Specific heat, SH. All right. It seems like a straightforward question. We just have to deal with that degrees Celsius somehow. So let's just see how we're going to deal with that. Well, what this question really wants is the change in temperature. That's what it's concerned with. And we look at these two numbers, and we have 30.0 degrees Celsius minus 23.5 degrees Celsius is going to, well, let's just bust out the calculator, because I know that's what you guys are doing. You can probably do it in your head, but that's okay. Minus 23.5 equals 6.5 degrees Celsius. So we're just going to increase the water's temperature by 6.5 degrees, and that's what we're going to plug in here. That's the number that goes there, 6.5. The change in temperature, that's the big business end, that's the key. All right, so let's plug the numbers in. Here we just rewrite the heat expression. Heat, think of that as energy, because that's what it is, heat energy, equals grams multiplied by change in temperature multiplied by specific heat. Now, a lot of students at this point just throw numbers up, and they leave the units out, and that can be detrimental. So make sure you put in the units. So that's going to become 1,000 decimal point grams multiplied by 6.5 degrees Celsius multiplied by specific heat, which is up here. 0.940 calories per gram degrees Celsius. Now here's why the units have to be here. And here's what the units will show you. They'll show you when you're wrong. And they'll show you when you're right. We need to be in a unit, kcal. That's what the question tells us we have to be in. So after doing all the cancellation down here, we should be in the unit kcal. If we're not, we have to either reevaluate what we've done or convert to kcal. Okay? So let's just start crossing out units. The grams will cancel. Degrees Celsius will cancel, leaving us in the unit calorie, not kcal. So we really can't leave our final answer as calories because the question specifically said kcals. So that's okay. We can fix that, not a problem. Let's just punch in the numbers real quick. 1,000 multiplied by 6.5 multiplied by 0.940 equals. All right, so let's write down that string of numbers. The calculator said 6,110 calories. That's not the correct answer. It's almost correct. It's definitely on the right direction, but it's not quite the correct answer. To figure this out, to go to kcals, which is what the question demanded we do, all we have to do is multiply, let me get a different color, multiply by something to give us kcal. Okay? We have to multiply by something to give us kcal. We'll put calories on the bottom, kcal on top. Now a kcal is a kilocalorie. So just like a kilogram is 1,000 grams, a kiloliter is 1,000 liters, a kilocalorie is 1,000 calories. So in every 1 kcal, there are 1,000 calories. So you divide the number by 1,000. Equals 6.11. Now, be very mindful. Be very mindful. In this equation, we had two significant figures, 3 and 4. So our final answer has to reflect that 2. And we're going to do that right here. The calculator says 6.11. We are the scientists, so we know we have to round that. And I'll just use a different color for dramatic emphasis. 6.1 kcal. And put a box around it. Okay? 6.1 kcal. Now, this is a lot of work. It's a lot of writing. But the question I don't think is very difficult. The first time you're seeing it, of course, it is very difficult. But I don't think it's all that bad. Now, my advice to you in a question like this, because there's a lot going on, is go ahead and try to do the very same question again. Just try it again. By doing this question again, you're going to prove to yourself that you can follow through the sequence, and you're going to practice it. Practice makes perfect. Practice, practice, practice. Okay? Now, if you're still having difficulties, if you still can't quite figure out where all these numbers came from and why they went where they went, go ahead and contact one of the tutors here at the Academic Success Center. They're here to help you. Or if you'd rather, come and find your professor during normal office hours and get clarification on this type of question. They're really not hard. They just look hard. They just look busy. Okay? But you can do it. You can do this question all day. And once you get the hang of it, you can do them with your eyes closed and in your sleep. All right? And with that, I bid you good luck and good chemistry.